Hey guys, this is it. This is the final lesson for this school year in Algebra 2 with trig. So, Chapter 15, Section 4. You'll notice that there is a video for Section 3. There's no narration, it's just the PowerPoints. If you want to go through that, and it's just how to use your calculator. Then, depending on your type of calculator, it's going to vary. So, you're better off, I just wanted to post that for you. You're probably better off just looking it up on Google or YouTube, and then you can figure it out for your calculator how to use your trig functions. So anyway, let's go on. Today we're going to talk about solving right triangles. First we're going to discuss significant digits, and then solving triangles, angles of elevation, and depression. Okay, so a significant digit is a digit obtained by actual measurement. So these significant digits in the following numbers are identified in the color blue. So those will be examples of digits or numbers that we collected in data based upon the measurements that are done. And this is something that's in italics, so there's a reason for that. It's important. Your answer is no more accurate than the least accurate number in your calculation. So let's say, you look at the last answer on the right, 7,300. It's not real accurate. How many people were there? 7,300. That's not as accurate as, let's say, 7,312. Okay, so keep that in mind while you're doing this work. So to determine the number of significant digits for answers and applications of angle measurements, use this table. The nearest degree, you answers to 2 digits. To minutes, or the nearest tenth of a degree, 3 digits. Minute, or nearest hundredth of a degree, that's 4 digits. And then 10 seconds, or nearest thousandth of a degree, then that is 5 digits. As a side note, to quickly remind you here, this here, when we go down to this here, those are the various, so degrees are, it's the way this works, you have degrees, and that's equal to 60 minutes. And 1 minute equals 60 seconds. So here's degrees, minutes, and then seconds, so that you know what you're looking at there. Alright, so to solve a triangle, that means to find the measures of all the angles and all of the sides of a triangle. So when you're doing this, you need to label your sketches, and you're going to have to draw a picture. So use A to represent the side opposite angle A, B, the length of the side opposite angle B, and then C, the side opposite angle C. Okay? In a right triangle, letter C is reserved for the hypotenuse. Alright, so and solve right triangle ABC if A is 34 degrees 30 minutes and C is 12.7 inches. So basically you can take that angle measurement and use sine and cosine to solve for A and B. So you would plug in the sine of A, which is 34 degrees 30 minutes, equals A over 12.7. So basically you would multiply each side by 12.7 and times the sine of 34 degrees 30 minutes and get approximately 7.19 inches. Then the cosine is equal to A over, the cosine of A is equal to B over C, so cosine of 34 degrees 30 minutes is equal to b over 12.7, multiply 12.7 by each side, and end up with approximately 10.5 inches. And you can basically, on some of your better graphing calculators, literally just type it in just like this for this here. Now you're going to have to convert 34 degrees 30 seconds to 30.5, right? Because that's half a degree. So on some of your calculators, you're going to have to actually do that. On others, you can actually put in the minutes and seconds. Okay. And then angle B, of course, we would just subtract 90 minus angle A, and 90 minus 34 degrees, 30 minutes, or minutes is 55 degrees, 30 minutes. Okay, so you could have found the measure of angle B first, and then use trig functions of angle B to also find the unknown size. So you can use this process a couple different ways, and all of them are going to produce correct answers. To maintain accuracy, always use given information as much as possible and avoid rounding off in intermediate steps. You should not round off until you're actually done, which is the reason why you actually want to use a calculator and a good calculator in solving this. Okay, so we want to solve this triangle, ABC, if A is 29.43 centimeters and C is 53.58 centimeters. So quickly we can do the sine of angle A. So that's the side opposite over the hypotenuse. And then you use the inverse function to find the number of degrees on your calculator. So you would put the sine of -1 and then 29.43 over 53.58 and hit enter, and you would come up with approximately 33.32 degrees. Then you could subtract that to find angle B and come up with 56.68 degrees, and then use the Pythagorean theorem to solve for B. Come up with 44.77 degrees. Now, when you are given you're given information that goes to the hundredths, that's where your answer should go, to the hundredths. Okay, angles of elevation and angles of depression. Excuse me. Think of it this way, as if you're standing and looking straight ahead with your eyesight and you are looking up at an airplane. That would be the angle of elevation. Your eyes going up to look at an airplane up in the sky. So that angle of elevation would be the difference between looking straight ahead and then the raising of your eyes. Angle of depression would be like, let's say you're standing on a balcony and you look down at the street at a friend. Okay, the angles of the degrees that if your eyes are looking parallel to the earth and then looking down at your friend on the street would be the angle of depression. Okay, so be careful when interpreting the angle of depression. Both the angle of elevation and the angle of depression are measured between the line of sight and a horizontal line. Okay, so doing some applied trig. First, you want to draw a sketch and label it with given information. Label the quantity to be found with a variable. Use a sketch to write an equation relating to the given quantities of the variable. And then solve the equation and check your answers make sense. Okay, so Shelley stands 123 feet from the base of a flagpole. The angle of elevation to the top of the flagpole is 26 degrees 40 minutes. If our eyes are 5.3 feet above the ground, find the height of the flagpole. So you're going to use that information to solve for the height of the flagpole. So the tangent of 26 degrees 40 minutes is equal to 123, or A divided by 123, so we would multiply each side by 123. 123 times the tangent of 26 degrees 40 minutes equals 61.8 feet. Then you add her height to the that level, and basically you come up with 67.1 feet. The length of the shadow of a building is 34.09 meters tall. Or excuse me, the height of the building is 34.9 meters tall, and the length of the shadow is 37.62 meters. Find the angle of elevation of the sun. So you go ahead and use tangent and use the invert function, and you find that the measurement of the angle is 42.18 degrees.
That's all, folks.
It's been a trip, guys.